Hey guys, this will be the video going over 3.5, 3.6. Should be pretty short, but as we did in class, I just recommend that for the notes on 3.6, make sure that you can do all the problems in there. I was going to assign that as homework, but we got through it all in class. So if you miss class, I would recommend doing all the notes, all the problems on the 3.6. Yeah. So, because we just have these 5 questions here on this assignment, which is definitely not enough practice to get it down. So that's my advice to anyone who missed class. Do all the notes, do all the problems there, do all the problems here, and that should be good. So for question 1, which of the following could be used to find the slope of the line tangent to the curve of this function right here? So which of the following, procedures maybe, is the correct way to find the derivative pretty much? The slope of the line, tangent to the curve, which is the derivative. So this is implicitly defined. We have y's and everything. We have my y's and x's together. So let's think about how we would do this. So I would just start by taking the derivative and seeing which one lines up with that. So when I take the derivative of arc sine, so I'm going to need the chain rule. So we'll take the derivative of the outside part, so arc sine. The derivative of that would be 1 over the square root of 1 minus 2x squared plus y squared squared. So this is the derivative of just the outside part. Now we have to take the derivative of the inside part. So multiplied by 4x plus 2y y prime. And that's going to be equal to the derivative of 2 over x. Well, that would be the same as the derivative of 1 over x times by 2. And the derivative of 1 over x is equal to negative 1 over x squared. So same derivative, just with 2. So negative 2 over x squared plus 2y y prime. So, let's see which of these match. So it's not going to be 1 because there is no chain rule happening for this part right here. And B, we do have 4x and 2y, but we don't have y prime, so they didn't use the chain rule when they took the derivative of y squared. So it's not going to be that one. You can see we have the y prime here, and everything checks out on the left side here. On the right side, we have, 4x plus 2y, okay. What is different about these two? I'm having a hard time seeing this. 4x plus 2y y prime plus 2y y prime. Oh, squared and not squared. Because I think we do have the same thing on this side right here. And then we have this over here. And so it's got to be C then. They didn't take the derivative correctly. This needs to be squared. So it's got to be C. Which of the following does not require the use of the chain rule? This A would require the use of the chain rule. We have an outside function. We have an inside function. So, yep. And then, let's see. Does this one require the use of the chain rule? Yes, this one requires the use of the chain rule because I'll have to use implicit differentiation here and here, which when I multiply by y prime, that's the chain rule. So it's not going to be A, it's not going to be B. Y is equal to 10 square root of x. No chain rule needed here, no chain rule needed here, no chain rule needed here. So I think it's C. And if we just verify D, we do have an inside part right here, and it's implicitly defined. So, yep, we would need the chain rule there. For 3, all right, so we're finding second derivative. So let's find the first derivative. So y prime will be equal to the derivative of function e is the same function, so e to the 2 of sine x, but we do need to multiply by the derivative of the inside, so we have to multiply by 2 cosine of x. So that's the first derivative. I'm just going to simplify. That's the same thing as 2e to the 2 sine of x times by cosine of x. So I'm just going to switch up the order of multiplication there. And now to find the second derivative, I'll take the derivative of this right here. So we'll have to use the product rule. So I'll do the first, and then multiply by the derivative of cosine. So that's going to be negative sine. So what I'll do, I'll put the negative here times by sine of x here. Plus, I'll take the derivative of this part. Now the derivative of this right here is the same exact derivative that the first derivative. So when I take the derivative, oh, except not with the 2. I guess that's, well, I guess the derivative of that, but I did reassign. Never mind. All right, so the derivative of that is going to be 2e to the 2 sine of x times by cosine of x. Now, this cosine of x is not this cosine of x. This cosine of x is the, I need to multiply by 2 cosine of x. Multiply by 2 cosine of x. So this 2 cosine of x is the chain rule for this function right here. It's the derivative of the inside. So we took the derivative of this part right here. So we have the 2. The derivative of this would be this times by the derivative of the inside. And now times by cosine of x. So times by cosine of x. This cosine of x is the same as, so these are the two same. And then it's probably just a little bit of cleanup for simplifying. So now what they're probably doing is they're probably factoring out the e to the 2 sine of x, and maybe even factoring out the 2. So this is negative 2 e to the 2 sine of x times by sine of x, and then plus 4 e to the 2 sine of x times by cosine squared of x. So the only thing that has cosine squared of x is this part right here. So I think it's going to be D. But again, to kind of match what they have, e to the 2 sine of x is in its own factor, or it looks like they even have 2e to the 2 sine of x. So it looks like they're factoring that out. So 2e to the 2 sine of x. And then when they factor that out here and the 2, they'll have negative sine of x. And then plus 2, because we factored out a 2, and they factored out the e sine of x. So then this would just be 2 cosine squared of x. So indeed, that is the same answer, so D. All right, for 4, let f be the function given here on the closed interval from 1 to 4. What is the instantaneous rate of change of f prime? So notice the wording here, instantaneous rate of change of f prime. Well, f prime is the instantaneous rate of change. Instantaneous rate of change of f. So that means f double prime is the instantaneous rate of change of f prime. So so that's kind of some tricky wording right there. What is the instantaneous rate of change of f prime? It's asking for f double prime. So basically the question is, what is f double prime of 2? That's what it wants. So f prime of x is going to be equal to, so we have negative 32 over x. Now that's the same derivative as 1 over x times by negative 32. If you think about it, this is the same. So I'm just taking the derivative of 1 over x. The derivative of 1 over x, like I mentioned way up here, is negative 1 over x squared. So then with that negative and 32, it's going to be positive 32 over x squared plus 3x squared. F double prime of x then, well, I'm going to rewrite this right here. That's going to be 32 x to the negative 2. I'm just going to rewrite it like that because it's just easier for me to take the derivative when it's like that. It's going to be negative 64 x to the negative 3 plus 6x. Yes. So that's going to be equal to negative 64 over x to the third plus 6x. That's going to be, and then, so that means f double prime of 2 is going to be equal to negative 64 over 8 plus 12. And that's going to be, isn't that like 64 divided by what? 64 divided by 8, isn't that just 8? So negative 8 plus 12, so that's going to be equal to 4. And for 5, this one's not multiple choice. This one is free response. So let f be an increasing function, all right, with f of 0 equal to 2. The derivative of f is given here. This is no calculator, by the way. So find f double prime of negative 2. So we have f prime. We want to find second derivative. So we'll take the derivative of that. So f double prime of x is going to be equal to, now the derivative of sine is cosine. So we're going to have cosine of pi x times by pi for the derivative of the inside. And then plus 2x. So there's our first, that's our second derivative. At negative 2, that's going to be pi times by cosine of negative 2 pi minus 4 when I plug in negative 2 there. Cosine of negative 2 pi, where's negative 2 pi? So negative 2 pi is going to be just right there. So negative 2 pi meaning it's going to rotate this way, clockwise, and then 2 pi degrees. So that means it's going to be 1. So we're going to have pi times by 1 minus 4. So our answer is, we can leave it at an exact format, pi minus 4. All right, for B. Write an equation for the line tangent to the graph of y equals 1 over f of x. So that's okay. Note that we're finding for this is the line tangent to the graph of y, not to the graph of f prime of the graph of f. And so we want y minus y1 equal to m times by x minus x1. We know x is going to be 0, so we know that much. So I'll say x1 is going to be 0. Y1 is going to be equal to, since we want it to be tangent to this graph, this is what we're going to use for y1 and for y prime. So this is going to help us find both of these right here. So we'll just plug in 0 right now, so 1 over f of 0. And f of 0 is given to us, right? F of 0 is 2, so y1 is going to be equal to 1/2. And then m is going to be equal to y prime at, so y prime is going to be equal to, so let's say this right here, y is equal to f of x to the negative 1 power. Yeah. Now, again, notation. This does not mean inverse. This is actually a negative 1 power. If it were inverse, it'd be placed here. Again, notation's whack. But so this is actually an exponent. And so when I take the derivative, that's going to be negative f of x to the negative 2 times by the derivative of the inside. So times by f prime of x. So y prime is going to be equal to negative f prime of x over f of x squared. And then we want, so m is going to be equal to y prime at 0. That's going to be equal to negative f prime of 0 over f of 0 squared. So f prime of 0 is going to be equal to, so we're going to plug in 0 right here. That's going to be equal to sine of 0 plus 0 plus 3. Sine of 0 is 0, so this is going to be equal to 3. And then f of 0, which is given to us, is 2. So this is going to be equal to negative 3 over 2 squared, so negative 3 over 4, because we have to square the 2. So this, our equation is this. So y minus a half, because that's what we have for y1, equal to negative 3/4, because that's what we had for the slope right here, and then times by x, since x1 is 0. So I think we can leave our answer like that. At least I'm going to leave it like that. So for C, let g be the function defined here. Find g prime of 2. So let's find g prime. So g prime of x is going to be equal to, so we'll need the chain rule. We'll have to take the derivative of f first. So that's going to be f prime of the square root of 3x squared plus 4. Then we'll multiply by the derivative of the square root, which will also need a chain rule. So this is going to require 2 chain rules. So we're going to have to multiply by the 1 over 2 square root of 3x squared plus 4. Then we'll have to multiply by the derivative of the inside here, which would be times by 6x. So, and now we want to find g prime of 2. G prime of 2 is going to be equal to f prime of, so if I plug in 2 right here, that's going to be 4, it's going to be 12, plus 4, that's going to be 16. So that's going to be 4 then. The square root of 16 is 4, so f prime of 4 times by 1 over 2. And then since this is the same thing, I plug in 2 right here, the whole thing's going to be 16. Then we'll do the square root of 16, so it's going to be 4. So times by 4 times by 12, right? Yeah, I think so. Maybe. We'll find out. Yeah. I guess we're just gonna find out. Does that sound right? The derivative of that is going to be 6x. Okay. So f prime of 4 is going to be equal to, I'll do that up here. F prime of 4 is going to be equal to sine of 4 pi. 4 pi is 2 complete revolutions of the angle. So here's 2 pi, here's 4 pi. So that's still going to be 0. And then plus, what are we plugging in again? 4? Yeah, f prime of 4. So that's going to be 16 plus 3. So that's going to be 19. So that's going to be 19 times by 12 over 8. Okay. Right. Whatever that becomes, I don't have a... Let's see. We can do some factoring. So that's going to be 19 times by 4 times by 2 times by 3. What am I even saying? I don't even know. That's going to be 4 times by 3 over 8. And 8 is 4 times by 2. Those cancel. So then we'll get 19 times 3, 19 times 3, 20 times 3, 60. So it's going to be 57 over 2. Okay, I think that's right. All right, D for the last part. Let h be the inverse function of f, find h prime of 2. So we're trying to find h prime of 2. What's that equal to? Well, maybe I can find f prime of, well, I don't know what I'm finding f prime of yet. I need to get the point. So let's find h of 2. What is h of 2 going to be equal to? Well, it will be helpful if I know what f of something that equals 2 And that's up here. F of 0 equals 2. So that means h of 2 is 0. Do I know what f prime of 0 is? F prime of 0, didn't we find that earlier? I don't remember. Well, let's do it now. F prime of 0 is going to be equal to sine of 0 plus 0 plus 3. That's going to be equal to 3. So it's going to be equal to 3, which means h prime of 2 is going to be equal to 1/3. Okay, and that should do it for this homework assignment.